Hi everyone, so I think we've pretty much completed all of the work that we can do at home. What I wanted to make sure was that everybody was comfortable with all of the individual terms and what they mean moving into our revision stage, okay? So we're going to go through the whole of the database design and development unit, looking at each of the topics individually and some of the key terms inside them to make sure that you understand them all. So let's start off with analysis, okay? In the analysis unit, it's really important to be able to, if you're given a scenario, pull out both the end user and the functional requirements, remembering that the end user requirements are what the user needs. They're kind of in layman's terms what the user's expecting the database to do. The functional requirements is taking these end user requirements and kind of starting to make a list for the developer of what it is they'll actually need to create. Now, this will cover things like the entities that will be required in the database, as well as specific attributes and how they should be split up. And also things that are specific about like sorting or calculations that need to be made against the database, or searches that might be able to be done and what impact that has on how the database is formatted or set up. So it's really important that we're able to do that from a set of either criteria that's given or input from various different people in the form of the speech bubbles that you've seen before. Okay. Topic 2 is looking at design. And it's quite a large section, okay? So we started off with entity relationship diagrams, making sure that we understood how they moved on from National 5 and the fact that we could use 3 or even more entities, and that all of the entities would have the entity names for each of the boxes, the attributes in the bubbles around the outside. We would have the name of the relationship. That's the important bit that a lot of people miss, of what is the connection between these two different tables or entities, and also the cardinality, being able to demonstrate that as a one-to-many, one-to-one, or a many-to-many relationship using either the crow's feet, a 1 to M, a 1 to N, a 1 to an infinity sign, or however you prefer to be able to display that. Okay, it's really important that that's all be able to be used, and obviously it doesn't all have to go in a line, so there's various different ways they can link together. It's really important to read your functional requirements carefully to make sure you understand where each of these entities link together. We also need to be able to use entity occurrence diagrams, which we introduced as part of Hire, making sure that we can look at sets of test data and understand how to either demonstrate relationship types, one-to-one, one-to-many, many-to-many, or how to read them from a given entity occurrence diagram. Okay. We then talk about compound keys, so that's looking at primary keys where you don't have just one field but multiple fields. That creates a compound primary key, I suppose, for each record within your database or each entry within your database. It's really important that we understand how they are shown on an entity relationship diagram and how they're shown in a data dictionary. So you're making sure that you've got more than one field listed as your primary key, and all of them together become the unique identifier for each field, or for each record, I should say. Then we move on to data dictionaries. Again, quite similar to National 5, but all the information is listed, which means you can be asked on any of it. So each data dictionary should have the entity name for each of the tables within your database. You should have your attribute names listed, which will match your entity relationship diagrams. You'll have primary and foreign keys, remembering that now at Hire, because we're working with more entities, we're likely to have more foreign keys than potentially you would have seen at National 5, and that also we've got the potential of having the compound key, so you might have more than one primary key identified in a table as well. That's really important to remember. Under attribute types, we've got our 5 main attribute types: text, number, date, time, and Boolean. Text and the number being the ones that are obviously the one used most often, text being the really only one that needs to go inside quotes, date does, and time does sometimes as well. And then we move on to attribute size. So attribute size is only used for your text field. You don't need to give sizes for any other fields. Under validation, we have presence check, which is the most important. It's got its own section of the data dictionary called required. And then our other types of validation, restricted choice, field length, and range, come at the end where there's any validation that needs to be required in the database. Also, you might find in the validation section of the data dictionary the information about where the foreign key links to. Really important not to forget that. And sometimes if you've got auto-incrementing field or attribute, then sometimes that's listed under the validation as well, because that happens automatically and therefore doesn't need to be validated as such. Okay, so that's something you can think of as well in your data dictionaries. The last part of design we moved on to was probably the hardest part, which was looking at query designs. Again, a level and a step up from what you did at National 5. We need to understand your tables or your entities and your queries. You need to understand what attributes are being brought out of them, what search criteria you're looking for, what order they need to be sorted in. And the biggest thing at higher is this introduction of calculations with their readable headings that might be required, and grouping where appropriate to make sure you don't have duplicate output from your calculation where it's not required. Okay, and then we moved on, taking those query designs into the implementation section. Okay, now the implementation or the coding for database design and development is all around this use of SQL. And as I said before, SQL is specifically listed here in the arrangements in your assessment is for learning document, which means that you will be asked to write code in your exam, in your tests, in your homeworks, are as part of your practical assignment, and you might not be given an example always. So it's not always about changing it. You have to understand the layout. So it's really important to make sure that you've looked over and you understand and remember the kind of grammatical layout of the different types of operations. Okay, so we've got update statements we need to understand. We've got select statements, which are the biggest one that comes up most often. We've also got delete and insert. They've not changed hugely since National 5. I have created a wee additional video just to add to your work for this week, just to make sure you understand what they are and how they're laid out and how they might be slightly different to National 5. Again, you might be asked to write them. Sometimes you're given one and you're asked to write about what the impact is. So it comes from both angles. You might be given code and asked to what it produces rather than just to write the code itself. But regardless of which statement type you use, you need to be able to use these specific different features within them. So we need to understand wildcards. Now there's 3 wildcards as part of SQL. We've got the underscore that's used for a randomized single character. We've got the percentage sign, which is used for a randomized random number of characters. And then we've got the star. Now the star is only used as part of calculations where you want to select multiple fields. The biggest place it's usually used is within the count function, where we put count star, which means count all of the fields or count all of the attributes within this database that match a specific requirement. So there's the 3 wildcards. Remember that when you come into school and we're looking at the practical aspect of that, you might have to change some of them up just to match what is required by the different database packages you're using, specifically Microsoft Access, if that's what you're going to be using. Okay. We then have a set number of functions, very similar to what we've looked at already in various parts of software design and development. So we need to understand the use of the min function, the max function, the average function, the sum, and the count. And I would also add that probably, although it's not specifically listed there, the round function is good to remember as well, okay? Especially if you're going to be using average. So min finds out the lowest, max finds out the highest. Average will take the average number of any list of numbers given. Sum will take each number and add up each of its values. So if it was a set of test scores, for example, it would add up all of the scores of everybody in the class or what was selected. And then count would just count how many scores there are. So that would use that to work out how many pupils you had rather than actually what the total score was. Okay, so we can use those functions and then move on to use them within computed values. Now, computed values could be any of those functions above, or it could be a more simple calculation. So star rating equals star rating plus 1, or adding 10% to the cost of something. Okay, and the use alias there, alias is your term that we've been kind of using readable heading because that's what it mentions in the appendix. But alias just means another name for. And quite often when we've got a calculation or a complex calculation happening, we would give it an alias, a nice readable heading so that it makes sense to the user when that is output. And that's something that you might evaluate your SQL statements on. We've then got group by, which is introduced newly because we've introduced computed values or calculations. What group by does is basically means that if there's any duplicates, it will group it so that each thing only comes up once. Very, very important for things like count, because with min, max, average, sum, they're only really given one answer back. When you're counting, you might be counting for various things. So you could do this for some as well, but you could be counting for various things, in which case it's good to group it by each of the things you're counting for, and it will give you only one output each rather than multiple. Order by is your sorting, straight from National 5, but obviously you can have complex sorts now, so you might be sorting on more than one field, and it's important to remember the one that's got precedence comes first. And then your where is what your criteria is. So that's using your wildcards, it's using your different aliases, it's using your different fields and coming up with what your criteria is you're actually searching for. You can see underneath it says you should be able to read and explain code that makes sense of all of the above different SQL statements. So you might be asked to write it, you might be asked to, you might be shown a bit of code and asked what the output of or what it does or what the impact of the database is. Okay, so really important to think about those different examples. Okay. Over the page is the bits that we haven't really done so far because we've not been in school. So testing, describe and exemplify testing. Basically at database level, all we're really expected to do is to make sure that any SQL statements that we have created work correctly. Now that's a lot easier to test if we're actually using a database because you can see the output of what's created rather than just trying to guess from looking at the SQL itself. A number of things to think of is, have you remembered to put in your equijoin, your primary to foreign key link? Have you remembered to list all of the attributes that were asked for? Have you remembered to put square brackets around readable headings or any fields that have symbols in them? For example, attribute names with symbols like customer hashtag that we had for the game rentals table. Do we have I'm trying to think of other examples of testing, anything really, just that's not being displayed correctly. You also could be, if you've asked for a readable heading and that's not been given, that could be an example of it not working correctly, but perhaps not displaying as described. Also things like forgetting a group by when you're doing account calculation, that means that your SQL operation isn't going to be working completely correctly because the output is given a little bit confusing and it's not going to be exactly as I was looking for. Okay, so testing is about really looking at a SQL statement and trying to see what is missing. And table aliases is one to think of about there as well. So table aliases is when you give your table a little a name that you can call to make your coding a little bit more quicker and more efficient. And if you miss any of them out but you've used them, then that would cause your SQL to break as well. So that's something to watch out for when you're doing any revision questions. And the last section is evaluation. So what we have to look at in evaluation is understand whether or not what we've created is fit for purpose and whether the output is accurate or not. Okay, so what we're talking about is evaluation of the whole process. So looking back almost to what the clients were asking for in the speech bubbles at the beginning of the task and saying, well, can we actually meet all of these requirements that were asked for by our users to begin with? So does the database store the information as we needed? Are the fields split or the attributes split effectively to be able to search on them correctly? Can we sort by this specific criteria that we've been asked for? And is all of our outputs accurate to what is actually been what's been actually asked for? Okay, so that's basically the whole database unit in a nutshell. Everything listed there that you might potentially come across in a set of questions. As I said, you've not done the practical part already, and we will have a go at doing that hopefully when you return to school. Okay, hopefully that helps you. You're going to get a set of revision questions to do for your task for the end of this week leading into next week before your short break, and then hopefully you'll be back in school to try some of the practical work. Okay, any questions and let me know. Speak to you later. Bye.